wires. The flywheel of the motorcycle has a set of permanent magnets which revolves around the stator and produces alternating current in the coils. Each output from the stator has different purposes, as shown here. The output for the ignition purpose is received from the exciter coil. This coil has a denser winding of thinner wire than the other coils to produce higher voltage for the ignition. This voltage is supplied to an electrical component known as the capacitive discharge ignition, or CDI unit. The connection for an AC CDI is shown here. The primary function of the CDI unit is to store electric charge and dump the stored charge when required. A capacitor inside the CDI unit stores the electric charge. Another component, known as a pickup coil, tells the CDI unit when to dump this charge. The pickup coil has a small magnet with a coil of wire around it. The flywheel has a small extrusion on its outer surface. As this extrusion approaches and passes the pickup coil, a small voltage is developed in the coil. This voltage is supplied to the CDI unit, which closes an electronic switch known as a silicon-controlled rectifier, or SCR. This will dump all the charge from the capacitor through the output of the CDI unit. To increase the voltage further, an ignition coil is used. The ignition coil is a step-up transformer which increases voltage up to 200 times the input voltage, which is sufficient to fire the spark plug. Several other factors contribute to the continuous operation of the engine. The intake and exhaust valves are controlled by using a timing chain, as shown here. As long as the engine is running, the crankshaft rotates and transfers power to the other components for proper operation. Single-cylinder engines generally use a counterbalance to reduce the vibration caused by unbalanced forces. The clutch helps in smooth transfer of power from the crankshaft to the transmission system. The transmission system helps in altering the speed and torque as per our requirement.